Okay, students, let us see the relative motion. The concept belongs to rain umbrella problem concept. You see, in this concept, it is very similar to the river boat problems. You know already on river boat problems in river boat problems. You know the river velocity VR and the boat velocity with respect to R and absolute boat velocity VB are there. In the same way, in rain umbrella problems also, if suppose you see there are two axes, this is let it be x-axis, this is y-axis. In x-axis direction, if the man is traveling in this direction, moving in this direction with a velocity of Vm, and the rain is falling in this direction with the velocity of Vr. So here you see in the place of river velocity there is a rain velocity is there. So here Vr is equal to rain velocity and Vm is equal to, in the place of boat velocity, Vm is equal to man velocity. And also you see here the velocity of boat with respect to R in the river problem. In the place of this one, there is a velocity of rain in the with respect to man, that is equal to Vr minus Vm, that is equal to, it can be written as Vr plus minus Vm. So here you see Vm is in this direction, minus Vm is in this direction, minus Vm. So the in this direction V or minus Vm. So you see this one in this direction, rains for not getting wet, the man with his umbrella should make an angle theta with the vertical. So let us see some problems on this concept. Students, let us see this problem. A man is walking with 3 meters per second due east. Rain is falling vertically downwards with speed 4 meters per second. Find the direction in which man should hold his umbrella so that the rain does not wet him. So the let us write the given statement. Man is walking, man velocity Vm is equal to 3 meters per second due east, and the rain is falling downwards with a speed Vr is equal to 4 meters per second. So let us draw the diagram for that. Due east in this direction, Vm is equal to 3 meters per second, and the rain is falling in this direction, so vertically downwards. So in this way the rain is falling V downwards, V R is equal to 4 meters per second. Find the direction of the man should hold his umbrella. To for not getting wet him, he hold his umbrella in the direction of the rain with respect to man. That means Vr minus Vm should we should find out this value in this direction only, direction value and magnitude. Also we should so see the direction of Vrm. V is in this direction, R is in this direction. Vr minus Vm. Vr in this direction. Minus Vm means this will be written as Vr plus minus Vm. Y minus Vm is in this direction. So this is 3. So the resultant is Vrm is equal to. So in this direction, the man should hold his umbrella in this direction for not getting wet. So this angle should be, we have to follow this one. We have to find this one tan inverse. right opposite side we are using 10 also 4 by 3. 4 by 3 means here this is 3 by 4 or 4 by 3, 10 inverse. So let us, we have to find this angle theta. Theta is equal to opposite 3 by 4. 3 by 4. So that means the angle is 37 degrees. So the man should hold his umbrella at the angle of 37 east of vertical. East of vertical. East of vertical, from vertical towards east. From vertical towards east. So let us see this problem, students. A man is walking with velocity 3 meters per second to east and rain is falling vertically downwards with a speed 4 meters per second. Find the direction in which man should hold his umbrella so that the rain doesn't wet him. So for doing this problem we should use the concept of relative motion. Let us first of all let us write the diagram. How this man is walking in this direction 3 meters per second. This is man velocity, and the rain is vertically downwards, so it is falling in this direction. The rain VR is equal to 4 meters per second downwards, it is falling. So now find the direction the man should hold his umbrella. So direction means how we can do, how much angle it is making. So for not getting the getting wet, you have to find the vector of velocity of rain with respect to man. In this direction only you will not get wet. So VR minus Vm, that is equal to VR plus minus Vm. So let us write Vm is in this direction, minus Vm is in this direction, minus Vm. So the resultant is in this direction VRM. So IVRM angle, making an angle theta here. So you see, if it is a ground in this way, we should hold the umbrella for not getting wet. The man should hold the umbrella. So this angle theta, which is vertical towards east towards east of vertical, this is called the angle east of vertical. Let us find this angle or this angle, both are equal. Yes, opposite angles. Let us write tan theta is equal to the direction tan theta is equal to opposite side Vm is equal to 3 by 4. That means theta is equal to tan inverse 3 by 4, that is equal to 37 degrees. So it must be an angle. Man should make an angle theta the east of vertical, or from vertical towards east. It is called vertical towards east of the vertical, or vertical towards east. It is called in this direction. You should keep the umbrella. Okay, students, let us see this problem. To a man walking at the rate of 3 km per hour, the rain appears to fully vertical downwards. So when he increase his speed to 2 km per hour, it appears to meet him at an angle of 45 degrees with vertical at the speed of the rain. So here in this problem you see there are two cases. One is the man walking with 3 km per hour, the other case 6 km per hour. But in both cases one is common, that is the speed of the rain. So let us see the speed of the velocity of rain VR is equal to AI cap plus BJ cap. By using this vector form we can easily solve this You see case 1. In case 1, the velocity of a man Vm is equal to 3 kilometers into 3 I cap. So I means it is in x-axis, this is in y-axis I cap. Now the magnitude of rain VR is equal to root over a square plus b square. This is the speed of the rain. He is asking who should know the values of a and b. Right, Vm is equal to it is given. So, and a man walking at the rate of 3 km, the rain appears to be vertically downwards. Appears to be vertically downwards means this is Vrm is equal to how much? So this is the velocity of rain with respect to man. In this direction only, the man is holding the umbrella. So that is Vr minus Vm. That is equal to Vr is here, Vm is here, a minus 3 I cap plus bj cap. This is Vrm, right? But he is given the condition is fall vertically downwards. So vertically downwards means the theta is equal to 90 degrees, no, 0 degrees. 0 degrees means you see here vertical direction, vertical direction. So here the value a is equal to, since it is vertical direction, a is equal to 3. So we got a 3, and again in the second case you see, say case 2, the man velocity Vm is equal to 6 I cap. The man velocity Vm is equal to 6 I cap. Vm is given here. So Vrm is equal to Vr minus Vm, that is equal to a minus 6 I cap plus bj cap, right? So but is in this case the man made him at an angle is 45 degrees next to tan theta is equal to 45. Since 45, that implies to a is here, you see a is equal to 33 minus 3 I cap plus b j cap. So a and b is both are equal, then b is equal to 3. B is equal to 3. This is modulus of b is equal to 3. So now the speed of rain Vr, speed of rain Vr is equal to root over a square plus b square. That means root over 3 square plus 3 square. That means 3 root 2 km ph. So this is the speed of the rain. Thank you.